Hi, to my esteemed viewers, welcome. My name is Buxton. Here we learn construction quantity surveying. So first of good, we've done quite a number of items which will be attached in the description of this video to get the playlist of all the items that we have covered. For today, I would like us to study how to estimate steel reinforcement quantities on the staircase. This is a very challenging one, and I would like you that we follow together so that we learn how to do that. First and foremost, I would like us to understand how exactly reinforcement for staircase is normally interpreted. That is very important. Looking at this, the details that are presented, for example, at this point we have what we call thicknessing. At the thicknessing part, we have some reinforcement bars. Normally, this is what we call a section. This is a section of a reinforcement of the staircase, indicating the reinforcement and how they have been placed. Okay. Alongside, we have a plan of the staircase represented, where my cursor is showing, while this is the detail. So the first important thing is for us to understand how this staircase has been presented. So looking at this drawing, there is the part where we have the thicknessing. That is where the staircase is starting from. Okay, and of course this staircase, if you can look from here, all these steps, they are the same. Okay, they are the same in that from the first flight, now the one that is upward, and the second flight that is now also going to be also upward, but then on the second phase from the landing. So in other words, look at this arrow. This arrow starts from, it shows you how the staircase is moving. So it means the base of the staircase is here. Okay, that is now from this thickness that has been shown, the thicknessing that has been indicated here. So looking at this, where my cursor is, that means that is the point where, let me show you with let me get an arrow so that you are able to see that better. So the thicknessing is where the base that is supporting the staircase. Basically, that is where the staircase is starting from. So if you can just follow my arrow, yes, so the arrow is showing you how exactly it's going. Okay, so looking at that, this thicknessing is the point that the arrow is indicating. Okay, then it means it moves upwards along that arrow, and when it does so, then you see the first flight, exactly where this arrow is pointing at. That is what has been indicated there. And then now you get to the landing. Okay, so when you get to the landing basically is this point. Okay, the path that I've cycled is where we have the landing, and the landing is here. So from there, then you now get to the second flight. Okay, this is the second flight. Okay, the second flight. Then this is the first flight, and the first flight is also shown there. Then here is what we call the thicknessing, and the thicknessing itself is at this point. Okay, so this is very crucial that you understand how exactly the drawing for the staircase is normally presented, because that is the basis. If you understand how that is normally presented, it's going to be very easy for you to interpret even what you have in terms of the reinforcement bars. So once you understand that, I've already indicated to you how the flights have been arranged and how exactly they go. So the next important thing is now for us to interpret these reinforcement bars and be able to measure them. Okay, so once we have that, I just want us to go straight to do how to do the estimation. So first and foremost, looking at the thicknessing, the one that we've just studied, at the thicknessing point, we have the reinforcement bars that are represented at the tips. The tips normally mean, for instance, the first one is at these bars. Okay, The tip normally mean that's a section, and for that section it's been cut across, so that that tip shows you that that bar is going on the other way. It's going across, it's not going along on any point. So the thicknessing, for instance, the one that have been shown here, how many are they and what is the size of those reinforcement bars. Okay, so just when I zoom it in, you can see there is a T12, and that T12, zoom it in properly so that you can see where it's ending. That T12 is ending, it's showing you this bar, the bar at the top. Okay, but I want us to start with the one at the bottom, including the one that has been spread at the thicknessing level. Okay, so I will follow through. At this point we have 48 02 200 B2. Okay, so the 48, you can see 1 2 3 4. Okay, so the T8 are the ones at the thicknessing level, and they are 4 number. You can see this is 1, this is 2, this is 3, and that is 4. So those bars, I would like us to go to the, when I told you when it's across, when they have been shown across, then it means when they're showing you at the tip of the bars, as they are showing for the thicknessing, then they have been cut across. Okay, it means because what we have at the thicknessing is spanning from this point to this point. Okay, so just check on my arrow. This is the point, this is the span where we have, this is the span where we have those reinforcement bars for the thicknessing, and there are 4 of them. Okay, so we need to know, and they have been cut across, to mean they have been cut in this manner, exactly where I've drawn, I've drawn my line. That is how the section has been drawn, but the bar is across it. So the length of the bar should be from this end point to the other end point. So to mean, as usual, as the way we measured for the concrete, it's normally very important that you take that length from extreme ends of the walls. So in this case, this is showing you it's 1200. So the 1200 is at the center, so we need to take from the extreme ends of the wall. So we add 100 to one point and 100 to the opposite point. So it means it's going to be 1.2 plus 0.2, that is going to give you 1.4 meters for these reinforcement bars at the thicknessing point, and they are T8. Okay, so when we start in our estimation from what we've been doing, those were beam reinforcement, and I just want to include here now these are staircase reinforcement. So I will start with T8. Yeah, normally you will realize that you will have number of them indicated in terms of the bar mark. So we have 1 2 3 4 and so on. So the one that we've talked about is having mark 02. So we can start with 02. T8 T8, or we do okay, T8 on caps, T8 02. Okay, so the 02 is the bar mark, and in this case the length that we've seen is 1.4. okay, 1.4. Just want to let me copy this, yeah, so that we have the calculation easier. Okay, let me paste it here. Yeah, so this is now reinforcement to staircase. So once we have that, this is now the ID, this is the diameter, the number, this is the length, total length for conversion. So do away with that C1 because those are the columns and we don't need them now. So we have that. So the ID is now T8 T802, that is bar mark 2. Diameter is 8. The number of the bars, there are 4, as you've seen there. The length of one of them is 1.4 meters. Therefore the total length is length for one bar times the number of the bars, which is 4. Okay, so the length conversion constant is 162, that is the constant, and therefore the weight of the bars in kgs is equals to diameter squared, okay, diameter squared times, let me just bring it there, times diameter squared times the total length divided by 162. That is the how to find the kgs for reinforcement bars. Alright, so we've done for 02. I would like us to move next to the one that is indicated 01. So bar mark 01. When I zoom it in so that you are also able to see it properly, it's indicated T12 bar mark 01, 125 is the interval B1 and T1. Okay, so what that means, the diameter of the bar is 12, the bar mark is 01. They are spaced as one at 125 for bottom 1 and top 1. Okay, bottom 1 and top 1. This bar is at top 1. When you look at it for the first area where it has been indicated, this is the one here, it's top 1. Okay, it's top 1 in relation to this bar. You can see there is a bar under it, so it's top 1 in that sense. But when you go to the side, to the thicknessing point, it's bottom 1. It's going to be the first layer of the bar at the base of this in relation to this point. So it's the same length, it's the same bar, but then it has been bent. So we need to get the total length of that bar. Then we multiply by the number of them appearing that are going to be used on the thicknessing at large. Okay, so what do we do? First of all, you can see there is a length that is covering at the waist part. Okay, we had understood, or we had learned that this is the waist. Okay, the waist is this point. So we had gotten the length of the waist, which let's revisit and find out what we had calculated. So we got the length of the waist while we are doing the concrete for the staircase. Okay, so in our previous session, while we are doing the concrete for the waist, we got the length of the waist, where we were taking we were getting by using the Pythagoras theorem, and we were able to calculate that, for instance, now this is the base. Actually, what we'll do, the base is equivalent to the whole of this length, while the height is equivalent to this, while the length is now the hypotenuse. And using that method, we were able to calculate that the height here is half of the 3000, which is going to be equivalent to 1500, while the base is equivalent to, you can see here it's indicated, there are 9 threads, each of them is 300 millimeters. So it's 9 times 300, which is 2700. So it means this base is 2.7, okay, while the height is 1.5. That is half of the 3000. Okay, the height is 3000, so we used a height of 1.5 meters. Therefore the waist here is the hypotenuse, and then so by using Pythagoras theorem, square root of 1.5 squared plus 2.7 squared gave us 3.1 meters for the waist. Can confirm that as well. So the 3.1 meters for the waist should help us to also find this length. And how do we do that? So this length of this turning bar, we always take a quarter times waist. Okay, so we take a quarter of the total length of the waist. So in this case, it's going to be a quarter times 3.1, and then we add these other parts. So this one we've already seen, it's going to be a quarter times the waist, should give us the all of this length up to this point. Okay, so when we get here, we need to find also this one, the 600. You know that we also have what we call concrete cover. So we take the total, which is 600, and we less the cover. And cover in this case, we'll treat this as part of the slab, and the cover that we're going to allow is 25 millimeters. So we'll less 25 here and 25 here. Okay, so we'll have this 600 minus 25 there times 2 for the cover, and then we add this portion, that portion that is standing there. And for us to get that, the total of this is the first one is the slab. Okay, and for the slab, it's the slab is 150. Okay, then there is this portion here that is coming, the one that is slanting. So for the slanting part, the slab itself is 150, but you can see it's not ending the whole of it. Okay, and this other one is also 150. The thicknessing is normally about also 150. So 150, and we'll take half of the slab, because that is the approximate of what we have for the part that is extending. So we take 150 from the bottom to the top, and then we add half of the slab, which is 150. We get a total of about 75. So that gives us 225 millimeters. Okay, that is 150 for the thicknessing down here, and half of the slab, which is half of 150, giving us 75. That is 225. So we need to add the 225 plus now the 600 minus the 50, and then we add a quarter length of the waist, so that we get the total of all that length of the bar as it's moving, or as it has been arranged. So let's add that and find the length that we have. Now let me just bring this. It's not showing me. Yes, this is how I want it. So let's see what we have. So in our length, let's go to, this is where we are doing it. Okay, so the reinforcement that are here, the one that we are doing, it's T12. That is the identification. So the bar is T12, 01. That is now the bar mark. The diameter is 12. Number of the bars. Okay, so you can see the number of the bars have not been indicated, so it means we have to calculate it. And as long as we know the span, and the span of the thicknessing from our plan is from this point to this point. Okay, so we got it to be 1.4, the total distance. So that T12 bar, they are going to be spread within that 12, within that 12.4. Okay, so the number therefore is going to be 1.4 divided by, what is the interval of the bars? The interval is 125. Okay, so divide by 0.125, and of course we are going to add 1 to it. Okay, so this gives us 13 bars. Seen that? Then the length of the bar, the length is the one that we were just discussing. We are going to start with a quarter of the waist. Waist is 3.1. So what do? We take 0.25 times 3.1, and then we we add to it 600 minus 0.5, okay, or this is 600 minus 50, basically gives us 550. So that is 0.55, then plus, here we've said it's going to be half of the slab plus 150, that is 225. That is giving us 0.225. So that gives us the total length of that reinforcement bar, each of them. So I mean the length of each of them. So the total length is the length of one times the number of bars that we have. Okay, length conversion factor is remaining to be the same, and the weight of the reinforcement bar is through the formula that we've done. Okay, so that is giving us the reinforcement bar for bar mark number 2. We move on to bar mark number 3. Okay, at number 3 it's T12 03 125 bottom 1. It's only laid at the bottom 1, and I zoom in properly, you can see the reference of the bar is this. Okay, so you need to check the extent in which that bar is moving. That bar is starting from the thicknessing, going all the way up to this point. This is where that bar is reaching. Okay, so to mean it's going to take all the length of the waist. The waist is 3.1. Then you add, it's ending halfway. We can estimate that it's halfway the landing, and the landing is 1 meter. Okay, the landing is 1 meter. So from the 1 meter we'll take, actually it's going all the way up to, if this is the landing, it's not even halfway, it's leaving a very small portion there towards the wall. Okay, so to mean we can take from the 1 meter we can take 800. Okay, so that means we'll take the whole of the waist, which is 3.1. okay, and the bar is T12. So how do we do that? We take the T12, this is 03 now. The diameter of the bar is 12. The number of the bars, so looking at the spread, the part in which it's spread, the same distance that we've used, because we use for the thicknessing, we use from this point to this point, and that is constant all the way. It's coming all the way to this other extent. So it means the span where it's going to be laid is the same, and you can see also the interval is 125. So that means the 13 is going to be the same, the 13 number of the bars. The length of one is equivalent to the waist, which is 3.1, and then we add then we add the landing, and the landing has been shown is 1, but then we are going to take 800, so that is 0.8. So the total length, we just multiply the length of 1 times that, and then the constant is going to be the same, and then the weight is going to be that way. Okay, then we move on to bar mark number 4. So that is bar mark number 3 is done. We go to bar mark number 4. So when you look at bar mark number 4, it's also at T1 and B1. So the T1 is the one that you can see here, but then it means that bar is also having to be a bottom 1 somewhere. So it means it's going to be bending somewhere. Yes, so look at this. You can see that bar, just follow it all the way. Let me zoom it in properly. It goes all the way. When it reaches here, that bar is bending down and turning that way. So it means it's a top 1 here, but then when you follow it along, at this point it's a bottom 1, at this point it's a top 1, and then it's a bottom 1 here. At the same time, it's a top 1 up here. Okay, So that is how challenging the reinforcement bars for the staircase is, but then you need to follow it very keenly. So it means you are going to get that all that length moving all that way, then when it reaches here, you follow it there, and then it bends up to this point. So from the first point, the first portion of it, we are going also to take a quarter. We are also going to take a quarter of the waist for portion 1. Okay, then portion 2, we are going to take the landing. The landing is 1 meter, so this is the landing, portion 2. Then this one here, we are going to take the slab. Okay, of course the slab is 150, or you can say the landing, but then we less the cover, so this is the portion 3. Then portion 4, we are going to take now, this is now the wall, and then we can add half of the landing at portion 4. This now portion 4. So let's calculate that length. So what we do, this is now number this is T12 bar mark number 4. Okay, this is T12 04. The diameter is 12, the number of the bars. Okay, so let's see what the number of the bars are going to be. So these bars at first point on this first flight, it's they are going to be laid at the point where the same interval as the one that we've done. Okay, and moving on to the landing, it's going to be the landing is going to be a little different, in the sense that it's going to be spanning the whole of that part for the landing. Okay, so alternatively, what we can do, because this reflection of the first flight, first flight and the second flight, in terms of how they join to the landing, is typical. So we can take for one part and then we multiply by 2 to reflect for part for first flight and then the second flight in their conjunction to the landing. That is alternative 1. So it means let's get the number first. The number is now going to be the same as 13, the way we've done above, because of it's still the same flight that we are dealing with. Then the length now, the first part, we are going to take 0.25 times the waist, 3.1. Then we add the second part is the same as the landing. The landing is 1 meter. Okay, and of course 1 meter, but then you add 200 for the wall, because you can see it's going all the way, so it's 1.2, but then you less the cover, which is 25. Okay, so that is 1.2 minus 25, so that is okay, so what we are saying is 1.2, but then we less 0.025 for the cover at that point. Then what is bending here, it's 150, but then we less 25 above and 25 below, so that is 150 minus 50, that gives us 100, that is 0.1, sorry. Then we add, now here at number 4, the one that is bending all the way and turning here, we take the whole landing, we take it halfway, and the landing the whole landing is 1 meter, so half of it is 500, but then we add the 200 minus the cover. Okay, so we take 500 plus 200, that gives us 700, minus 25, that gives us 700, and actually 600, no, I'm saying 500 plus 200 is 700. 700 minus 25 is 675. Okay, so that gives us 675, so that is 0.675 as the total length, as in the length of one bar. So the rest of the formula remains in place to get the weight. So that is how technical it appears, but then it's very simple once you understand how those bars are flowing. So I said that in that relation, what we have, actually just confirm, this is bar mark number 4. So we'll take that bar so that we equate it to, or we adjust for what we have for the second flight. We need to do that, multiply that times 2, the weight that we have, because of the landing adjustment. So we do that times 2. Alright, so that was bar mark number 4. Looking at this, which one else could be left? We have we are done number 2, we are done 1. Okay, I can see 2 bar mark 2 there twice, but then we haven't done this other 2 at the bottom, which is for the waist, and you can see how they are spreading. So how do you interpret this? Normally, when you see this is called, they are numbered already. We have 30 T802, 200 B2, and top 2. Okay, that means we have 30 of those bars, and the span in which they are placed is from here to this point downwards. So it means they are the bars that are cutting across, the bar that has been shown by the tip of the bars. These are the bars. Okay, all the way from here going up to this point, and they are at bottom 2 and top 2. So bottom 2, it means these ones, they are coming second at the bottom of the staircase, and then they are also top 2. Okay, they are also top 2 in the sense that they are also laid on top of another bar. So this is bottom 1, and then top 2. Let me see where the top 2 are. This is 48. Yes, it looks like the top 2 that they are also referring to are these ones here, the ones that we had done. So in this case here, the first interval, actually the top 2, we are not going to deal with them, they are here, and then bottom 2 are well, in this interpretation we have top 2 and bottom 2. We can see the top 2. I mean, we can see the top 2. We already dealt with bottom 2. So what we do, the 30 they are cutting across because they are represented at the tips, and the number is already given. So what's of essence is for us to get the total, the length of one, which we had already found, because that particular length is similar to what we had already found. We had already calculated in the first 02 bar mark, and the length we had already calculated. So what we do, the first 02 is here. So in this case, we just need to add that number because it's the same, and they are the same bars. Okay, so this is 4, but then we now we take this is now equal to 4, but then we add the 30. Okay, we added the 30 bars, and then it works out everything for us because the formula is already in place, and the length of those bars are the same. Okay, that is 02 is complete, 4 is complete, 3, 1 is complete. Then we have also this is now 8 T8, 10, 200 B2, and top 2. Okay, so what this means is that in this case what we have, let's see, whenever you see the that arrow indicating, then it means those bars are cutting across. It means they are the bars that are represented at the tip, and they are for both bottom 2 and top 2. Okay, bottom 2 are these, okay, and then top 2 are these ones here. Okay, yes, top 1 is what's at the top, and then top 2 is now the ones below. Okay, yes, actually the same explanation applies to the one that we've just done for this number 2, where we have bottom 2 is here, and then top 2 is here. Total number of the same is 30. Of course, they are number 2, bar mark number 2. That even signifies that they are of the same length. So what we've done is just correct. So this 30 we add to the other 4 that we've dealt with. Okay, spanning between these points. So just to make a correction on that, the one that we've done, the 30, it's spanning from here to the top here. So it means they have been laid across only at this point. At the bottom, these ones that you can see, and then at the top are these other ones, top 2. Alright, well noted. So the next point is 88, 10. So that is the bar mark number 10. And they are bottom 2 and top 2. Bottom 2, I've just put a tick there. Then top 2 are these. Okay, there are 8 of them. Okay, so the 8 of them, they are cutting across the landing. Okay, so when they are across, if they are across the landing, then the length of those bars is equivalent to, you can see here we had the landing. The landing is 1 meter, but then that is now along. So for them, that is across, that is on the shorter side of the landing. Okay, of course the 1 meter is this, but then the bars that we have are across that length. So it means they are from this end, they are going that way on the longer dimension, and the longer dimension, it's equivalent to this is 1.2. So we take it complete. So that is 2.4 plus the wall 0.2 and another 0.1 and another 0.1. That is 2.4 plus 0.2 gives us 2.6 meters. Okay, so this is let's get back to our detail and see what we have. Our detail is saying it's there 8 number, and they are T8. Okay, so this is T8 bar mark number 10. So the diameter is 8. How many of them are there? Okay, so we've seen the length, but then now for the number, we are supposed now to find, because this is the bar on the longer side, on the longer part, but then now for us to find the number, it's now the 1 meter divided by the interval. Okay, actually we won't even need to calculate, they're already indicated as 8. Okay, so the number is 8. The length of the bar is equal to we've said 1.2 for the half, so times 2, then we add 0.1 times 2. Total length, the formula is already in place for us. This one is also in place, and the formula of the other part is also in order. So we move on to bar mark number 5. So bar mark number 5 is T1205 125 B1. So it's only at the bottom one. Okay, take note of that. So the length is equivalent to the length of the waist, because you can see it spanning from this point going all the way up to here. Okay, so that is bar mark number 5, and the length or the diameter is that is T12. Okay, so we have T12 bar mark 05, diameter is 12, and the number of those bars, they are going to be, they are on the longer along the waist, but then they have been spread on that single flight. So it means it's the flight is 1 point, we got 1.4. Okay, so for the 1.4 is what we divide by 1.4 divided by 1.4 has been divided by 0.125, which is the interval, and then we add 1. So the same calculation we had done, and we got 13 number. Okay, so the length of them, length of one of them is equivalent to the length of the waist. Of course, when we add the bends on top and the bottom, we should get there it is the length of one is 3.1, that is equivalent to the waist. Okay, when we add the bend at the top, which you can add like 0.2 on either side, we get 3.5. Then now the total length, the formula is in place, and the rest of the items as well. Okay, so we have that. Alright, so the next one we are doing is this is also another 02. You can see this is 23, T8, 02, 200, B2, and T2. So they always the basis is we get the total reinforcement for a whole floor, and then we'll be multiplying by the number of typical floors. Okay, so that is why we need to do it all the way from the first flight and the second flight combined, and then we'll multiply that the kgs that we shall find by the times the number of all the other floors. So in this case, this is 23, T8, 02, 200, B2, and top 2. Okay, so the same explanation we did for the one the one that we did here is the same that we're going to adopt for this at the top. So it's B2 and top 2. To mean B2 is this, it's bottom 2. I mean bottom 2 laying on top of the longer one that we've done, the bar mark 05. Okay, then top 2 means these ones here, the one that I'm showing. When you can see if you can see my pencil, then you're able to see that there are 23 of them. Okay, the length is going to remain the same across the flight, across the 1.4 meters meter distance. Okay, so let's get to work. This is T8 bar mark number 02. Okay, so even that means we can add it here, and for the number there are 23, so we need to add 23 to this, so we add 23 here. Length is the same, total distance and everything, so it means the formula is going to reflect on itself once we've added that particular length. So this is the essence of normally arranging your work in that manner. When you do so, you find out it's going to be easier for you to carry out those works, because whenever you see the mark is similar, then it's most likely that the length is typical. So just add the number. So we go to bar mark number 6. At bar mark number 6, yeah, we're just completing that. Bar mark number 6, it's a top 1 and a bottom 2. So top 1 and bottom 2 would mean top 1, it's this is the bar. Okay, then it goes all the way to become a bottom 2, and bottom 2 where? Here. So it means it's going all the way and then bending to become a bottom 2 at that point. Okay, so what that's for us to get the length, therefore, is going to be, you can see this has been given. We have an 800 here, and then we have this one going all the way from this point to this point. So it's going to be, we normally take let's see, you can see here has been indicated as 800, and 800 is not ending, it's not taking into consideration this portion here. So that is why I normally insist that we take a quarter of our this is a quarter of our waist, that is. Okay, so what we have is going to be, this is T1206. Okay, this is T12 bar mark 06. All right, so the diameter is 12. The number of the bars, it's not been indicated, but then we now need to calculate it. The interval is 125. So for 125, the same argument we did for the other one, which was done in relation to the landing, is what we are going to do for this case as well. You know that we have like this now to the slab. Actually, these are the slab level, but then that additional weight of the reinforcement must be taken into consideration, and the reason being even at the slab, you are not going to consider it the same as what we have for the reinforcement of the slab. Okay, this is dealt with as staircase independently. So what we do, we've already indicated the other descriptions, so we are going to deal with it as one flight at the interval of 1.4 meter. So the length, let's get it bit by bit. So the number of the bars is equivalent to the 13 that we had already calculated. Okay, and then for the length is going to be, we took 0.25 times the 3.1. What does that come to? That comes to 0.777, and then we add, now let's make the adjustment, then we need to add also on the other part is 0.8 on the end, on that other ending, on that other landing, that is 0.8. okay, so that gives us the full length, and then now the length of just one, then we do that, and we also copy this formula, and we copy this one as well. Alright, and oh, let me see if at all. Oh, we only multiplied, okay, that times 2 has been done twice, but it's not right. We only did for twice for bar mark number, that was bar mark number 4. Yes, bar mark number 4. So this is the one that should be having the times 2. These other ones shouldn't be by 2, so I need to delete that. Yeah, so that is how keen you should be, so that you don't repeat. But then here we need to have it times 2 based on what we've done. That is now bar mark number 6. We need to multiply by 2. So taking on, we've done 0.2, we've done 0.5, 0.6 as well. So that is basically the complete estimation of the reinforcement for one flight, I mean for one floor, okay, both of the flights. So what we need to do, we now need to get a total of this, which is just getting the sum. So when you get the sum of that, we add, so this is the total for one floor, okay, for one floor. And then actually what we need to do, because we are going to assort them based on the sizes of the reinforcement, not actually based on the element, then we now need to multiply by the number of floors that they appear. So how many floors are here? So having confirmed that what we have in these the staircase, they're identical, therefore we need to multiply by the number of floors, because what we've done is for our whole floor, both flights. So we'll take the weight that we've just calculated times their 5 floors, which are typical. So we copy the same all the way. So once we've done so, then we are now going to see which other reinforcement for which other element is left. So we've done columns, we've done beams, we've done staircase. Of course, we still have slab, which is also another very critical one that is also posing a lot of challenges, but we are going to calculate it one by one till it's complete, and we are very okay with it. So this brings us to the end of our session today for what we needed to cover, and we've just done the reinforcement for staircase. If need be, any question that you might be having, just put it at the comment section. I'll answer to each and every one of them. Having done that, even if this is not properly in, there are going to be more coverages of staircases of different types of reinforcement until we fully benefit and fully understand what is expected and how exactly to go about them. So thank you very much for turning up to this session and watching, and I believe that it has been worthwhile. For any of the upcoming videos, if you don't want to miss, please just make a subscription, and then we'll be moving together as one. Thank you very much, and welcome again to the next session that is coming very, very soon. Have a great time till we meet again in our next session. Bye bye.